For over a century, we thought Antarctica was simple: ice, rock, and silence. We were completely wrong.
In February 2026, scientists catalogued 207 volcanoes beneath the ice, most of them unknown, many potentially active. In January 2026, the most advanced mapping technology revealed Earth's deepest canyon, buried for millions of years. And in 2025, microbiologists discovered 1,374 new species in a lake sealed beneath a kilometer of ice. Antarctica isn't frozen. It's breathing, lakes fill and drain, rivers flow in darkness, volcanoes generate heat, and life thrives where it shouldn't exist. This is the story of what lies beneath Antarctica, and it's nothing like what we expected.
Antarctica has inspired wild speculation for decades: secret bases, ancient pyramids, hidden creatures. But the verified discoveries we're about to explore are far stranger than any conspiracy theory. And unlike fiction, these mysteries remain unsolved. What we examine today is the verified scientific record, discoveries made through advanced technology and peer-reviewed research. As we shall see, the reality beneath Antarctica's ice surpasses any fiction.
For most of recorded history, our understanding of Antarctica was straightforward. The coldest, driest, most remote continent on Earth, covered in ice averaging 2 kilometers thick. The prevailing assumption was that beneath this ice lay simply frozen bedrock, nothing of particular scientific interest. That assumption was incorrect. In the 1960s, scientists began employing radio echo sounding, specialized radar capable of penetrating ice. Radio waves transmitted through the ice sheet reflect back differently depending on what they encounter. Rough, scattered signals indicate bedrock. Smooth, bright reflections indicate liquid or water.
Initial surveys identified only a handful of lakes. Today, we have documented over 400 subglacial lakes beneath Antarctica's ice sheet. What makes this discovery particularly significant is that these lakes are interconnected through an extensive network of thousands of subglacial rivers.
Perhaps even more remarkable is their dynamic nature. These lakes undergo cyclical filling and draining events. Billions of liters of water can surge across hundreds of kilometers in a matter of days. Satellite laser scans allow us to observe these events from space. As lakes fill, the ice surface bulges measurably upward. When they drain, the surface subsides. The continent, in effect, breathes. The largest of these subglacial bodies is Lake Vostok. Its dimensions are extraordinary. 250 kilometers long, 50 kilometers wide, roughly the size of Lake Ontario. What distinguishes Lake Vostok scientifically is its isolation. It has been sealed beneath 3.5 kilometers of ice for an estimated 14 to 25 million years, sealed off before modern humans evolved. A preserved sample of an ancient Earth. The possibility of life within Lake Vostok has been the subject of considerable scientific interest. Russian researchers successfully drilled to the lake in 2012, but concerns regarding contamination have complicated efforts to definitively characterize any potential biosphere, so the question remains open. But the implications of what might live there extend far beyond Antarctica. Lake Vostok's conditions, sealed beneath kilometers of ice, isolated for millions of years, potentially harboring unique ecosystems, mirror the suspected conditions on Saturn's moon Enceladus. In 2005, the Cassini spacecraft detected geysers erupting from Enceladus's south pole, suggesting a subsurface ocean beneath its ice shell. If we can't even sample Lake Vostok without contamination concerns, how will we search for life on Enceladus without destroying the very evidence we're looking for? Antarctica is our testing ground. The challenges we face here will determine how we explore ocean worlds elsewhere.
However, we need not speculate about the existence of life in Antarctica's subglacial environment. We have already confirmed its presence elsewhere.
Blood Falls. The name is descriptive, not metaphorical.
Blood Falls is located within the McMurdo Dry Valleys, one of the rare ice-free regions of Antarctica. These valleys constitute less than 1% of the continent's surface and rank among Earth's most arid environments. The landscape bears such striking resemblance to Mars that NASA utilizes it as a terrestrial analogue for planetary research. In 1911, geologist Thomas Griffith Taylor, a member of Scott's Terra Nova expedition, discovered a blood-red discharge flowing from Taylor Glacier. He hypothesized that algae were responsible for the coloration. Subsequent research proved otherwise. The discharge is ancient seawater, trapped for 2 million years, 3 times saltier than the ocean, loaded with iron that bleeds red when it meets air. But the color isn't the mystery. What lives in that water is. The truly significant discovery came in the early 2000s. Microbiologist Jill Mikucki of the University of Tennessee confirmed that blood falls harbors living bacteria. These microorganisms have persisted for 2 million years in complete darkness, near freezing temperatures and virtually no free oxygen.
They have evolved an alternative metabolic pathway, extracting chemical energy directly from minerals in the bedrock through chemosynthesis, deriving energy from inorganic chemical reactions rather than from organic compounds or photosynthesis.
This discovery fundamentally expanded our understanding of the environmental parameters within which life can persist, and it caught NASA's attention. Bloodfalls became what scientists call a Europa analogue, a terrestrial preview of what we might find beneath the ice shell of Jupiter's moon Europa. If bacteria can survive here, in ancient brine, in total darkness, for 2 million years, then similar life could exist in the subsurface oceans of icy moons throughout our solar system.
In 2018, the Subglacial Antarctic Lakes Scientific Access Project, SALSA, successfully drilled through more than 1 kilometer of ice to reach Mercer's subglacial lake in West Antarctica.
The samples revealed 1,374 distinct microbial genomes, most of them new to science. These organisms can survive with oxygen or without it, eating organic matter or extracting energy from bare rock. Ultimate survivors.
This research has attracted significant attention from NASA and other space agencies. If life can persist beneath Antarctic ice under these conditions, similar life could potentially exist beneath the ice shells of ocean worlds such as Jupiter's moon Europa or Saturn's moon Enceladus. Antarctica serves as a terrestrial analogue, informing our search for extraterrestrial life. Yet the discoveries beneath Antarctica's ice extend far beyond biology. The Denman Canyon remained unknown until December 2019, when glaciologist Mathieu Morligem's team published the most detailed topographic map of Antarctica's bedrock. The project Bed Machine Antarctica synthesized nearly 1 million line miles of ice-penetrating radar data collected since 1967. The Denman Canyon extends 3,500 meters below sea level, the deepest continental canyon on Earth. It had remained hidden throughout the entire history of Antarctic exploration. Bed Machine revealed far more. Entire mountain ranges lie buried beneath the ice, peaks rivaling the European Alps, valleys comparable to the Grand Canyon, sharp topographic transitions indicating ancient tectonic boundaries previously unknown to science. In January 2026, researchers published an even higher resolution map utilizing ice flow perturbation analysis. This method models ice flow dynamics to infer bedrock topography at unprecedented resolution, revealing previously undetected features: massive subglacial troughs, alpine valley systems, and entire physiographic regions now being formally named for the first time. Antarctica possesses a complex, varied landscape that has remained invisible beneath its ice cover until now. In February 2026, researchers from China's Polar Research Institute published the first comprehensive catalogue of Antarctica's subglacial volcanoes. The catalogue documents 207 volcanic edifices ranging from 100 meters to over 4,000 meters in height. The majority are concentrated in West Antarctica, along the West Antarctic Rift System.
Critically, these are not extinct volcanoes. Many are likely active or dormant, capable of future eruptions. They generate significant geothermal heat, melting ice from below, creating subglacial water reservoirs, and influencing ice sheet dynamics.
At least one is clearly active. Mount Erebus has been erupting for over 5 decades, a streak of volcanic activity stretching back to 1972. The heat from the volcano creates warm caves nearby that are home to some strange life forms, mosses, algae, and mysterious organisms with DNA, unlike anything else on Earth. These are more than biological curiosities. They're a roadmap for where to look for life beyond our own planet. Scientists suspect similar systems, where volcanic heat meets polar ice, could exist on Mars. If life survives there today, it might be hiding in environments exactly like these Antarctic caves, which is why NASA's missions in the 2030s are specifically targeting regions where ice and volcanoes intersect.
What we learn in these caves could guide us to life on another planet.
The significance of these discoveries extends beyond scientific curiosity. The water beneath Antarctica is a primary control on ice sheet behavior. When a layer of water forms between the ice and the bedrock, it acts like a lubricant. This reduces friction at the base, allowing the entire ice sheet to slide much faster toward the ocean. Consider the Thwaites Glacier in West Antarctica, often called the Doomsday Glacier. It sits directly on top of massive subglacial water systems and volcanic heat sources that act like a lubricant for the ice. Because of this, it's one of the fastest changing glaciers on Earth. If Thwaites were to collapse on its own, it could raise global sea levels by over 0.5 meter. But the real concern is the domino effect. Its collapse could destabilize the glaciers around it, triggering a massive cascade that reshapes our coastlines forever. Complete collapse of the West Antarctic ice sheet would contribute approximately 3 meters to global sea level, sufficient to inundate major coastal cities worldwide.
Right now, Antarctica is protected by the Antarctic Treaty of 1959, which sets the continent aside as a scientific preserve where military activity and mining are strictly banned. But there's a catch. The treaty is up for review in 2048.
This looming deadline has sparked a quiet but intense international race. Nations are rushing to expand their research today because a scientific presence now creates a footprint for the future. If the treaty's protections are ever renegotiated or rolled back, those footprints could become the basis for territorial claims and a fight for the resources hidden beneath the ice. Everything we're finding under the ice today will eventually dictate the reality of life on Earth in the coming centuries. One final mystery warrants examination. In 2009, researchers analyzing gravity satellite data detected an anomaly in the Wilkes land region. A circular structure approximately 480 kilometers in diameter exhibits a gravitational signature inconsistent with surrounding geology. One hypothesis proposes an impact origin. A massive asteroid strike approximately 250 million years ago, coinciding with the Permian-Triassic mass extinction, the most severe extinction event in Earth's history, eliminating 96% of all marine species. If confirmed as an impact structure, the Wilkes land anomaly could represent the trigger for this catastrophic event. The impact hypothesis suggests the collision-induced massive volcanic eruptions on the opposite side of the planet, the Siberian Traps, releasing enormous quantities of greenhouse gases and driving runaway climate change.
However, definitive confirmation remains elusive. Alternative hypotheses propose volcanic or tectonic origins. Diagnostic evidence of impact has not been recovered, buried beneath kilometers of ice.
Definitive resolution requires direct sampling of the bedrock. To date, no such mission has been attempted. The mystery persists.
Our technology is advancing, but it still has blind spots. Features smaller than 2 kilometers or larger than 30 remain invisible, which means undiscovered structures almost certainly remain.
Undiscovered features almost certainly remain. Drilling technology is similarly advancing. The SALSA project employed hot water drilling, high-pressure heated water that melts through ice rapidly while minimizing contamination risk. Future technologies under development include autonomous underwater vehicles capable of exploring subglacial lakes independently and next-generation ice-penetrating radar with enhanced resolution. Each technological advance reveals previously hidden aspects of Antarctica. We are in the early stages of this exploration. Consider what has been discovered beneath Antarctica in merely the past few decades. Over 400 interconnected subglacial lakes linked by thousands of rivers, transporting billions of liters of water through absolute darkness. 1,374 newly identified microbial species capable of surviving without sunlight, expanding our understanding of life's fundamental limits. Earth's deepest continental canyon, concealed for millions of years. 207 subglacial volcanoes generating geothermal heat, potentially influencing ice sheet stability. And possibly the impact structure responsible for Earth's most severe mass extinction event. Yet, our exploration is far from complete. The Wilkes land structure remains an enigma, and Lake Vostok, the crown jewel of these subglacial systems, remains largely unsampled. Each answer generates new questions. Each map reveals unexpected features. For a century, we saw Antarctica as a frozen wasteland, static, dead, and unchanging. We were wrong. Beneath the ice, an entire world breathes. Lakes fill and drain. Rivers flow in darkness. Volcanoes smolder. Life persists where it shouldn't exist.
Right now, satellites are watching the ice surface bulge and subside. Drilling teams are preparing to pierce Lake Vostok's ancient seal. And somewhere beneath 2 miles of ice, 207 volcanoes wait in silence.
We don't know when they last erupted. We don't know what lives in the deepest lakes. We don't know what triggered Earth's worst extinction. But we're about to find out. The mystery isn't what lies beneath Antarctica anymore. It's what happens when we finally reach it. If you want to stay at the frontier of these discoveries as the ice continues to reveal its secrets, subscribe and join the conversation in the comments about what you think remains hidden below.